In this lecture, I will explain you a bit more about distributed databases. A distributed database is a system that consists of loosely coupled sites that share no physical components. This is what Wikipedia says about distributed databases. To get the idea, let's have a look first at the traditional databases, which are not distributed. ACID-compliant relational databases like MySQL, PostgreSQL, Microsoft SQL or Oracle are typically running on a single machine or a set of closely coupled machines. This is typically the database that we had on the architecture diagram in the previous lecture. Typically, writes go to a single machine, as you can see on the right, where we have our master database where the writes go to. Reads can come from any replica, which means that we can add as many servers as we want, but we cannot send writes to it. We can only read from it. Of course, we can always read and write to the master, but we can only read from any read replica. We can also use failover by using a standby. Sometimes you can read from the standby, sometimes it's not allowed. A standby is kind of the same thing as a read replica, but it can also automatically become a master. When the master is not working anymore, we can then switch over to this standby node and use this standby node as a master. And then later on, when the master joins again, we can make that a standby node. If you would be able to write to any other node than the master, you would break ACID compliance. ACID stands for atomicity, consistency, isolation, and durability. It's a set of properties to guarantee that database transactions are processed reliable. If you would be able to write to multiple instances in traditional databases, you might end up with inconsistency between the nodes. Therefore, it is not possible to do this in the traditional relational databases. It doesn't mean that it doesn't exist. There are cluster alternatives to make one of the traditional databases distributed, but the traditional setup of a MySQL or a Microsoft SQL is still that writes can only go to a single machine. On the other side, distributed databases store data across multiple computers. Writes and reads don't become the bottleneck because they can be distributed over all the nodes. So here we can write and read from every node, not just one. Nodes in distributed systems can often be added easily, allowing to scale horizontally instead of vertically. Vertically means adding more resources like CPU, memory, disk. Horizontally means we're going to add more instances. We're going to add more nodes to our distributed database cluster to scale horizontally. A distributed database can scale much better than traditional systems, allowing for a much higher throughput and less latency. Querying the data unfortunately isn't as straightforward as relational databases. Managing a distributed database can be more challenging. You will lose a lot of features like joins, like it's often not very simple to use joins just like relational databases, to give you one example.